I will discuss addition of vectors, or on how to determine a resultant vector using analytical method, or also known as the component method. We will do plotting of vectors on the Cartesian plane. So to the right, we'll have a positive x component, and to the left, we'll have a negative x component. Upward, we'll have a positive y component, and downward, we'll have a negative y component. We will apply our knowledge in Pythagorean Theorem, wherein we have the formula: the sum of the squares of the legs of a right triangle represented by A and B is equal to the square of the hypotenuse represented by C. And we will also apply our knowledge on the three trigonometric functions with the acronym SO, CA, TOA. SO stands for sine theta is equal to the opposite side divided by the hypotenuse, or CA, which stands for cosine theta is equal to adjacent side divided by the hypotenuse, or the TOA, which stands for tangent theta is equal to the opposite side divided by the adjacent side. Let us now solve sample problem number 1. A dog goes 15 meters east, turns 8 meters south, and then goes 10 meters 35 degrees west of south. What is its resultant displacement? To solve the problem, we are going to tabulate all the given information and the x and y components. We will now plot the vectors starting with displacement 1, which is 15 meters east. So the vector will be going to the right with the magnitude of 15 meters. So its x component will be 15 positive because it is going to the right, and its y component will be equal to 0 because the vector is within the x-axis itself. We'll now proceed to displacement 2, which is 8 meters going south. So the vector will be this one, and it is 8 meters going south. So its x component will be equal to 0 because the vector is within the y-axis, and its y component will be negative 8 because it's going downward. Let's proceed to displacement 3, which is 10 meters 35 degrees west of south. So its vector will be it forms an angle of 35 degrees. So constructing a right triangle in here. So this will be the y component, this will be the x component, and this will be the hypotenuse, which is 10 meters. So for the x component, x is opposite to the angle, and with the hypotenuse, we'll be using sine 35 is equal to the opposite side divided by the hypotenuse, which is equal to x over 10. Simplifying, this becomes 10 times sine 35 is equal to x, wherein using your calculator, 10 times sine 35 degrees will give us a value of negative 5.7. So this will be negative 5.7. Let's proceed to the y component. So the y is adjacent to the angle and with the hypotenuse, so we'll be using cosine 35 degrees is equal to adjacent side divided by the hypotenuse, which is equal to y over 10. Simplifying, this becomes 10 times cosine 35 degrees is equal to y, which is, from your calculator again, 10 times cosine 35 degrees will give us a value of negative 8.2. So this will be negative 8.2. So the x and y components are negative because the vector is found at the third quadrant. So to get the summation of the x components, so we will add 15 plus 0 plus negative 5.7 will give us a value of 9.3. And for the summation of y components, 0 plus negative 8 plus negative 8.2 will give us a value of negative 16.2. So, plotting the summation of x and y components, we will have for x, this will be 9.3, and then the y is negative, so going downward, so this will be negative 16.2. So we'll construct a right triangle so that this will be the resultant displacement dr, the direction of which is angle theta. So to determine its direction, we'll be using the information on the opposite side and the adjacent side to the angle. So we'll be using tangent theta is equal to opposite side over the adjacent side. So this will be equal to negative 16.2 divided by 9.3. Theta therefore will be equal to, so with the help of your calculator, negative 16.2 divided by 9.3, and then you press the shift tangent or the second function tangent of your calculator, and you will get the value of negative 60 degrees. Or this means that it's 60 degrees south of east. So this will be 60 degrees south of east. To determine the resultant displacement, we are going to use the Pythagorean Theorem. So, dr therefore is equal to the square root of negative 16.2 squared plus 9.3 squared, which will give us the value of, with the help of your calculator of course, we'll have 18.7 meters. So, the resultant displacement therefore will be 18.7 meters, 60 degrees south of east. Let us now proceed to sample problem number 2. An airplane flying due west at 100 meters per second is blown by a strong wind at 300 meters per second, 40 degrees west of north. What is the airplane's resultant velocity? Again, to solve the problem, we are going to tabulate all the given information and the x and y components. We will now plot velocity 1, which is 100 meters per second going west. So this will be the vector, wherein its magnitude is 100 meters per second going west. So its x component will be negative 100 because it is going to the left. And its y component will be equal to 0. Let us now plot velocity 2, which is 300 meters per second, 40 degrees west of north. So, it forms an angle of 40 degrees from north going to west. So, this will be the vector, forming an angle of 40 degrees. Then we will draw a line, okay, to produce a right triangle, wherein this will be the y component and this will be the x component, with the hypotenuse, which is given 300. So, for the x component, the x is opposite to the angle, and we have the hypotenuse, so we'll be using sine 40 degrees is equal to the opposite side divided by the hypotenuse, which is equal to x over 300. Simplifying, this becomes 300 sine 40 degrees is equal to x. Using your calculator, 300 times sine 40 degrees will give us a value of negative 192.8. Negative because it is going to the left. So this will be x component will be negative 192.8. Let's proceed to the y component. So the y is adjacent to the angle and we have the hypotenuse. So we will be using the cosine trigonometric function. So cosine 40 degrees is equal to the adjacent side over the hypotenuse, wherein adjacent is y divided by 300. Simplifying, this becomes 300 cosine 40 degrees is equal to y. So your y, therefore, using your calculator again, cosine 40 degrees times 300 will give us a value of 229.8. So this will be positive because it's going upward. So 229.8. So we will now get the summation of x components. So negative 100 plus negative 192.8 will give us a value of negative 292.8. And the summation of y component will be 0 plus 229.8 will give us a value of 229.8. So we will now plot the summation of x components and the summation of y components. So this will be going to the left because it's negative. This will be negative 292.8 and then positive upward. So this is 229.8. Connecting this with a line, so we'll be forming a right triangle. So this will now be your resulting velocity, wherein its direction is this angle theta. So using this information, we have this side adjacent to this angle, we have this side opposite. So we'll be using tangent theta is equal to the opposite side divided by the adjacent side, wherein the opposite is 229.8 divided by negative 292.8. Okay, so our angle therefore will be equal to, with the help of your calculator, 229.8 divided by negative 292.8 is equal to a particular value, and then you press the shift tangent button of your calculator or second function tangent, then you'll get a value of negative 38 degrees or 38 degrees north of west. So this will be 38 degrees north of west. To determine the resultant velocity, we are going to use the Pythagorean Theorem. So this will be the resultant velocity is equal to the square root of 229.8 squared plus 292.8. So this is negative value squared, wherein with the help of your calculator again, 229.8 squared plus negative 292.8 squared is equal to, and then extract the square root, you'll get a value of 372.2 meter per second. So this will be 372.2 meter per second. So that's it. Thank you for watching, and please subscribe now.